This year, spectacular thing, the opportunity came up for Ryan and I to do this. And yesterday, last night, I was at the launch pad, this Cygnus expanding capabilities. Well, Cygnus, as you may or may not know, our guy Sean's going to talk about that. Cygnus, and it's the Northrup Grumman product. But it launches 3.5 hours or so from my home, and we're all working from home. So I said, this is perfect. I'm going to drive over and watch this night launch. And then I'm going to come back, and we're going to hear Sean talk about how we do it. Well, yeah, as you may or may not know, things happen with launch activities. This one was not unlike that. But it was quite exciting for me to be there and look at this thing and potentially watching this thing, and then come back and hear Sean, who is so spectacular. He's been involved in this activity. We have the fortune of getting him because he's been involved in this activity for a number of years. And if he was still involved with this activity, we wouldn't be getting him to talk about it. So his fingers are still wet and hot off of the Cygnus Antares project, and it just became perfect. He's a perfect person to discuss this. Now, with that said, here's Sean off to my right. Sean, I'm going to hand this over to you, and I'm going to get back and get quiet because y'all didn't come to hear Ryan and I talk. You came to hear Sean, and so we're going to do that. Sean Tully, go ahead. It's all yours.
Oh, thank you very much, Tom, and thank you very much, Ryan. Yeah, I'm really happy to be here. I'll just jump right in and go into a quick bio about myself. But before I do that, I do just want to thank all the sponsors that are allowing me to, come here and talk, allowing everyone to get together. Obviously, when Tom reached out asking if I'd be available to do this, sounded like a great idea. Seems like a great people for people in all sorts of technical industries to get together and talk about these things. So real quick, just a quick note about myself. So I'm a Virginia Tech alum, George Washington University alum. I've been working since 2006 at Orbital Sciences. For those of you that aren't as familiar with the space industry and the comings and goings of various companies, Orbital Sciences merged with ATK and became Orbital ATK, and then very shortly thereafter was acquired by Northrop Grumman. And we've been operating under Northrop Grumman for I guess it's been maybe just over 2 years now. Tough to say because the time certainly flies. What I really wanted to talk to you all about today, though, was the Cygnus product line, which is a spacecraft which I'll jump into history for. But 2008 is when I started on that project. I started on it from day one. I've been working on that project since actually this year. I'm still involved with it, just not as detailed involved as I used to be. I've actually transitioned over to our HALO program, which we do as well out of Northrop Grumman and Tactical Space Systems. But a little bit about myself so you know where I'm coming from. It's always important to get that context. I started out as a guidance engineer, specifically working on rendezvous and proximity operations for the Cygnus spacecraft. And I'll tell you a little bit about what the Cygnus spacecraft does and why that's important. I then transitioned to systems engineering. I was heavily involved with our integration and test phase. So a lot of the tests that we do on the manufacturing floor and a lot of the tests that we do with our customers. And then from there, I've done various block modifications on the spacecraft. And eventually, I was the chief engineer on the spacecraft on the product line. And since then, I've actually transitioned off, and I'm now supporting the chief engineer's office for the HALO program. So that's enough about me. What's really cool is, well, here's a few more fun pictures just to kind of brag a little bit about some of the things that I've been able to do. At least for this program, I've been able to do spacecraft design. I've been able to do software design. I can actually claim that I have code that still exists on the spacecraft. I've done integration and tests. I've actually, put things together on the spacecraft. I've tested the components. Done software tests, unit tests, functional tests, you name it. I've gotten to support launch campaigns, mission operations. I've been able to go up in front and speak to the customer. I've been able to see all of our operators and offer training and things like that. So I've really had the fortunate, just the opportunity to be able to do a lot of that. A couple of the pictures there, you see the group, and I always like showing group pictures because there's no one person that does any of that work. It's hundreds and hundreds of people that get together to do something as difficult as space systems and space logistics is. But that's actually us in front of the Orb-2 mission, which is almost years ago. But that is the Antares rocket behind us. I'm going to focus only on the Cygnus spacecraft, just because that is what we do here, and that's my expertise. But if you have questions about the rocket, I can try to answer them the best I can. A couple of other pictures are from our control room, which we actually handle in Dulles, Virginia. You know, sometimes we like to dress up for some of the missions. We don't do that as much anymore, just because, to be honest, after you do so many missions, it's hard to come up with creative new ways. But the one above was actually a throwback to the Apollo era, which we did with the skinny black ties and the white shirts. And the other one was for the Rick Husband mission. He had we always name our spacecraft after fallen astronauts or fallen leaders in the industry. And that particular astronaut, Rick Husband, had an affinity for Hawaiian shirts, so we wore that as an homage to him. As you can see, I typically grow facial hair. I'm a little superstitious, so when we get near missions, you usually find me with some sort of beard. It doesn't grow in so much here, but actually grows in. I can grow a pretty fine goatee, so I'll let that go and then eventually shave it. My wife hates it, but you know, you can't mess with tradition. Okay, so that's enough about me. You don't want to hear about me. You want to hear about the spacecraft because that's the cool stuff. So I'm going to talk about what's Cygnus, and then I'm going to talk about development operations. I know with this crowd, I mean, you can, of course, ask me questions if you need to, but I feel like this crowd probably already has a good, strong concept of DevOps, so I'm not going to try and bore you with that. And then really what I want to talk about is merging DevOps into a spacecraft product line and spacecraft design, and to talk about how those two worlds actually merge and connect very well. So what's Cygnus? All right, so Cygnus, it's a product line spacecraft. It's manufactured by Northrup Grumman Space Systems here in Dulles, Virginia. We also do some of the integration work in Wallops Island. It was actually developed under the COTS program. So it was a Space Act agreement with NASA. So it was a joint development program. Orbital Sciences at the time put up money, NASA put up money, and then came up with a new spacecraft to deliver cargo to the space station, as well as developing the Antares rocket. One of the big drivers for this is just to get a commercial style program into service for NASA JSC to support the space station. With the retirement of the shuttle, they were really looking for more efficient and more cost-efficient ways to get cargo to the station. And the other big thing that I want to point out is that it actually is a service that we provide. We don't actually build them the spacecraft. We are providing them the complete cargo service. So they hand over their cargo to us, we take receipt of it, and then we send it up to the space station for them. It is no different than FedEx or UPS. It's just a few more miles to travel. But for all intents and purposes, I mean, we do deliver cargo, and that's exactly what we do. And it's going to be important later for a couple of other charts to keep that in mind, that we are providing the service to them. Cygnus history. So as I said, in 2007, 2008 timeframe was right around when the COPS program was started. And essentially what happened, NASA had if you read the history on it, NASA actually was developing with another company, but they had some funding issues, and they reopened the bid, and then we were able to step in. We were able to leverage heavily off of existing product lines that we already had supporting for commercial customers, government customers, and we were able to take a lot of those designs and fold them through into our spacecraft design. And that's one of the big benefits, is to be able to take very big equipment and be able to figure out how you're going to integrate that into a different mission. And if that's one of the things we learned today, going through this whole agile process, we have to focus on, all right, how do we take what we have existing and focus on trying to get that into the field for something else. It took a little while to get to the maiden flight. Obviously, spacecraft design doesn't happen overnight, and there are a lot of safety hurdles and a lot of other issues to overcome. But we completed our critical design review in 2010. So for those of you that aren't design engineers, you typically have a straightforward design path where you go from your requirements review to your preliminary design to your critical design to where you're actually cutting metal, and that's the more traditional design process that a lot of people learn in school, and it might be a little bit old school now. But by 2013, we were able to complete our maiden flight, and we were able to put spacecraft completely into service. So around 2013, though, and for those of you that know a little bit of history about the space mishaps, you might recall that in 2014 we had a little bit of a mishap with one of our Antares rockets, which actually led to the loss of that mission, unfortunately. We obviously couldn't recover that cargo. It failed pretty spectacularly on the pad, although miraculously enough, it didn't do as much damage as you would think it would look when you watch the videos. But that also gave us an opportunity. We already had plans to make major modifications to the spacecraft anyways, and we were able to pull a lot of those plans forward to actually recover. So we made major modifications to the spacecraft, which you can see here in the chart. You can look at the size of it. We were able to grow the cargo volume and increase it by an extra 30% to provide way more volume for our customer. We were also able to change the interface as well, which led us to be able to choose multiple rockets. So while we were still trying to recover on our launch vehicle side to refurbish the Antares rocket and to go through that whole redesign for that to make sure that failure didn't occur again, we were able to actually go to another launch vehicle, and we were able to complete a total of 3 missions outside of KSC using United Launch Alliance's Delta V rocket. But a couple of the other major modifications we made, we completely revamped the propulsion system. We made the structure way more efficient, and you can also tell the solar arrays definitely changed designs there. The solar arrays that we have now are they're way more compact when stowed. They're actually way more efficient from a mass perspective. Okay, so after 2016, going into 2016 to 2018, again, NASA's, they're continuously sending up cargo up to the station, and because we were doing so well at the time, we basically offered just extension options and just kept sending spacecraft under original contract. But NASA was already realizing that they wanted to get more capabilities from their cargo providers, and at the time, SpaceX and Northrop Grumman were the only ones sending up cargo. So they actually reopened a continuation of that contract. So the old one was commercial resupply services, and they basically just said, we're going to call it and we're going to put a 2 after it and not get too creative. So the Cirrus 2 design came out, and we were selected for that, and we were able again to make major modifications, not to the point where we would have to completely bring the design all the way back, but just significant improvements where we could get the most capabilities out of what we were doing. So what you can see in the picture there, if you compare one of the, I believe that's actually the NG-11 mission to the NG-12 mission, we gave them increased thermal capabilities, so they were able to put a lot more powered components inside the cargo module. One of the problems you have in space, if your heat has to go somewhere, and if you power something, it generates heat. We're also able to put it in life support systems so that we could supply for like live science experiments or any other live materials. Not quite enough for a human. Cygnus isn't, it's human rated from a safety perspective, but it's not really designed to carry humans. Although I will add that one of the other things we were able to do, we were able to also make internal modifications on there, whereas why humans can't launch inside of a Cygnus or fly inside of a Cygnus, we were able to provide lab capabilities. So when the space station was running out of lab equipment space, we were able to put a lot of that equipment in, and the astronauts were able to do additional work, which they wouldn't have been able to do, and additional experiments were able to get up. Again, the name of the game is trying to get as much capability as possible out of the assets that you already have. And the space station is a very big asset, and it has a lot of opportunities to do a lot of things. And if you have questions about some of the stuff that they do, I'm not always the most qualified person to answer those questions. That really goes to NASA. I am merely the UPS driver. But one of the also major modifications we made, we also modified the hull of the pressurized cargo module and actually allowed us to plug in additional disposal cargo. And that's one thing I didn't touch on, but one of the major other benefits of the services that we're able to provide is to basically haul all their trash away. And the space station does, a lot of times experiments get sent up and they get used, and usually they don't know how long they're going to use them for, so they might be in a pinch. They might need to be able to get rid of them to make space for something new. So we basically offered that service where we said, look, if you have a couple of things you need to bring down, you can just plug them into the side of our spacecraft and we'll take care of them for you, and we'll do a destructive reentry and dispose of them for you, so that way you don't have to worry about them later on. So again, I talked a little bit about services, the fact that we're providing services. So here's one of the other major modifications that we made. So what you see here in the pictures, you actually see the Antares rocket coming down, and that little room on the bottom right picture that you see to the left is actually what's called the Mobile Payload Processing Facility, and that plugs right up against the rocket. And then if you look in that picture in the top, those are our employees loading in time-critical hardware for NASA. So for those that aren't, haven't brushed up on your space mechanics, it's not always easy to get to a place on orbit really fast. Sometimes you have to wait, on the specific timing or a specific time of day based on the time of year to hit the point that you want to hit. So we were able to make modifications where we guarantee NASA that, if you deliver us cargo, we'll get it there at least within 96 hours. And to be honest, almost all missions we beat that. 96 hours is just the max number that I wanted to beat. So right here you can see NASA has just handed over that cargo, and our team is about to go in and install it. And they have direct access into the spacecraft, and then once they're done, they'll button everything up, close off the top of the rocket, move everything up, and then the top right you see the Antares rocket ready to go with all of our payload. And this has become a huge benefit of just because, trying to get time-sensitive cargo up there, and it's not always, we're not talking deli meats and cheeses, which I know is on this mission, but it's usually critical science experiments which need to get up there, and the crew members need to work on it at a very quick time. And also, if we have any scrubs, and it didn't happen on this mission, but if they need to replace any of the cargo, if there's a launch scrub, we're able to bring the rocket down, get in there, access it, do all the work for NASA, and then close it back up and then send it back up. So it does give them a little bit of last minute to change your mind. Okay, so that's Cygnus. And there's a whole reason why I tried to talk all those points, and I promise this will come to an area where it's going to make sense from a DevOps perspective. So DevOps. So again, I'm pretty sure everyone in this session is very familiar with DevOps. It's been around for a little while, and actually I'm going to talk a little bit about some of the timeline from my perspective. But just in case, for those that need a refresher, the concept behind DevOps is basically to try and shorten software development cycles, but also I'm going to talk about how it actually shortens hardware and just general design cycles, with the idea of taking your developers who are doing a lot of your design and coding and getting them in the field to work with operators who are actually deploying it and using the applications, and getting that feedback loop in there so that you have your developers constantly talking to your operators. To give an idea of the timeline, though, and just to put it in perspective of where Cygnus is at, right? So for DevOps, everyone has a different background, and depending on when you were introduced to it, you might have heard it a little bit, earlier, a little bit later. But in general, 2009 is right around the time frame that DevOps is really starting to get into the industry and get in the technical industry for engineers and software developers to actually start getting their hands on. And the first State of DevOps report came out in about 2012. Well, if I compare that with where Cygnus was at, we were starting to develop Cygnus around 2007, 2008. And right around when we got our first mission out was about 2013, and we've been operating it since then. So, a lot of the Cygnus development as a product line actually occurred in parallel with a lot of the advancements that have been made in DevOps. And, as someone who's, taken Agile classes and trying to just stay with the most latest, trends in how we do our work, it's actually a lot of parallels with what Cygnus was doing, and actually we can kind of draw how that program and that design cycle was managed, and draw those parallels to the core tenets of DevOps. So how do we do that? So if we look back at Cygnus, for the most part, it is a service-based contract. So we had we were able to have basically all of the operators and the engineers work together. And we did work that with NASA overseeing everything that we're doing because we have to go to their station. But for the most part, our flight controllers and our operators, we actually were able to pull them in. So our design engineers really are the same people that are doing the coding and building that you would think of in a DevOps perspective. And we have a group for integration and test for engineers. They're really responsible for building and testing. But you notice in there that I also showed the flight controllers are testing. And we are actually able to pull a lot of our flight controllers, people that are operating the spacecraft once it gets into service, we pulled them in years before we were going to fly to actually test on the spacecraft. And there's numerous times where we actually had, a mission director sitting next to a systems engineer, sitting next to a software engineer, and they're all three of them working together to test the spacecraft and evaluate it. Our design engineers are then always responsible for reviewing and releasing test reports and able to see that. And before they actually, start, working on updates and getting those out to the floor, whether they be hardware or software updates, we're able to push those to the floor and actually coordinate that again with our integration and test engineers. So you can see from a Cygnus perspective for the development of the spacecraft, we were able to constantly have that feedback loop, which is the core principle of DevOps, which is to have your operators and your designers constantly talking together so that you don't have to wait for perfect information to get to the floor, have someone work it, write up a problem report, send it back, and then you just kind of, you kind of go back and forth. By actually putting them on the floor together, it's amazing how many problems got resolved before they actually even had a chance to become problem reports. And again, so how do you do this though? And that's the tricky part, right? So one of the first problems that we came up with to overcome was to get a test platform which is able to connect the spacecraft to all the people that it needs to talk to. So how do you get a spacecraft on the floor thinking that it's on orbit and getting it to talk to other facilities? So without giving too much of that secret sauce away, I'll cut to the chase. In general, we were able to make test equipment that was able to talk outside of just where it was, and we had to make significant investments so that way people could just come in and fly the spacecraft. In case in point, at about 2010, we had a room in our control center filled with engineers. For 24 hours, we pulled them in and had them run the spacecraft through its paces, and all of them were seeing spacecraft data. That spacecraft wasn't flying in orbit, that spacecraft was sitting on the ground. And that is an expensive test when you think about it, because it's a lot of people in the same room. However, in that room and in that session, we're able to get all of the problem reports discussed immediately, and then and basically just find problems before they were going to exist on orbit, or before someone was going to read a test report and then look through the data and find that something wasn't working. They basically were working it, raise their hand, said I have a problem, pull an engineer over, find out what the issue is, and then get it solved. I like to talk about that one specifically because we actually found what I would like to think of 5 different bugs that could have been mission-ending bugs for the first flight. But anytime we've had a block modification, we've actually been able to go in and get that tested and get it figured out very quickly. Okay, so how do we actually kind of see this in the field, with an existing product line once it's flying? So, one of the other nice areas that we have with our service is that we're able to constantly schedule flights. Now I understand that there was a scrub last night, but in a general perspective, if you're able to hit within like your 5-day launch window of when you plan to fly, you're actually doing pretty good. And last night was actually interesting because there is three scrubs pretty much all at the same time in their counts, all at the same time on different providers, which is definitely odds. The odds for that aren't too high, so I'm kind of thinking about getting a lottery ticket. But no, so for each mission though, once you get into a service, then you're able to feed that onto each other. So as you can see here, here are all of our missions just based off the timeline to show where they were. And you can see that there's that gap there between Orb 3 and OA4, which happened at the end of 2014, which I talked about before. But in general, though, once you have a mission every 6 months, you're actually able to pull a lot of that data forward, and it might not be useful for the next mission, but it's useful for the mission after that. So we have this feedback loop, again, of operators immediately going in and feeding that back to the engineers who are doing the design work. We also pull in our design engineers to actually operate our missions in a support mode as well. So they're able to see those things and get them fixed immediately, immediately in terms of space terms, but also to be ready for the next mission, which we've seen numerous cases before where we find maybe one sort of anomaly and then we pick it forward for the next mission. So specifically from a hardware perspective, again, some of the technologies that you can use, at the bottom there, I point out 3D printing technologies. The ability to rapid prototype has definitely changed the name of the game in terms of hardware engineering. We can immediately print mechanisms up to do fit checks and even hook them up to the spacecraft, or we can do any sort of additional checks or any sort of interfaces with temporary equipment until we're ready to go through and do a full-on metal design. But again, I want to point out that DevOps really only works when you apply the communication between the different teams. So you have to have clearly defined ICDs, or you have to be able to get the communication between one subject matter expert and another subject matter expert to pull them together so that they can actually figure out what they need to do. And that is one of the core principles for DevOps, is to just make sure that you are evaluating your team and then you can actually see where they're talking and where they're not talking. Again, I pointed out continuous review of existing hardware and getting feedback from engineering to the designers or operators to the engineering team, back and forth. A lot of times, we'll have our control boards where we're evaluating problems or tickets or service tickets or whatever terminology you're using, but essentially you have people in a room that are taking a look at all of the problems and then trying to figure out what you're going to do about them. We make sure that we have to pull people from all sorts of different disciplines in there, so that way we can get a good perspective of exactly what's going on. Again, trying to utilize standard interfaces as much as possible. That is one of the areas. I think I saw recently that Apple is considering, or maybe they are going to USB-C. And again, that's just an area where, if there's a standard interface that everyone is starting to use, let's, go off and use it and try to simplify your design so you're not constantly reinventing things that have already been solved. And again, I've also talked about early hardware prototyping. So this goes beyond 3D printing. This could be making, if you're in the electrical engineering field, this might be creating brass boards, or this might be getting development kits for your FPGA hardware. So it goes beyond just the strict software perspective. I mean, you can definitely do this from a hardware perspective. And again, areas where I talked about change control boards, depending on what terminology you use for your change control boards, in general, if someone finds something that they want to fix or something they want to change, they have to be able to justify that, both from a business case, but also from, a level of effort, so that basically people can understand exactly what the impacts of such a change are going to be. Someone who's putting forth a change might not even understand their full impacts. So you always have to make sure that you have a group of people that's able to understand exactly what's going on. From a hardware perspective, I just want to point out that, from DevOps, I mean, you can change a lot of those words in that DevOps lifecycle and take them to get them to apply to the mechanical perspective. So if you were thinking of code, well, that might be your design. That's actually someone going into CAD and trying to make their bracket or whatever they're making. And if you're going from building, well, you're not really building code at that point. You're actually getting the CAD models released and turning them into drawings. And for those, you might not be able to actually test those. You might have to put that through a series of review. And if you are designing a mechanical structure or mechanical housing, a lot of the operating might actually just be installation. So it might be the installer that's working it, and you might not be able to see someone who's actually physically operating it. So what I would say is, you can definitely take those processes and those ideas and turn those into, just turn the terminology different, so that way you can actually get them to focus on your specific engineering field. Quick signs of success. Oh, and I do see some questions there. I'll actually, those are really good questions. I'm gonna get through this, and then I promise I only have a couple more slides, and I'll get to those questions that I see in the chat window. Signs of success. Again, scheduled performance is the key indicator that I like to use. We've been able to hold our schedules. I actually have a plan from NASA, a flight plan that is from 2016 that had the flight plan listed all the way up to 2020, and all of our missions have actually been within the month that they were planning to fly, and most of those delays have not actually been because we weren't ready. Most of those delays are just because it had to do with cargo timing of when they actually wanted to send their cargo up. So we've always been ready. We've never made our customer late. I will also say the major block modifications, which I talked about, occurred on the 084, the NG9, and the NG12 missions, and we were able to get those major block modifications in. And you notice, besides the 4.1, which again was a little bit more difficult of a modification to make, as well as switching to a new launch vehicle, that's not as easy. But the 9 and 12 missions, you can't even tell if you look at a schedule that a major block modification there occurred just by looking at the schedule. You'd assume that you're flying the same thing over and over again, when that wasn't actually the case. The quality of the mission performance also, while taking the Orb 3 mission out of it, we've actually had all of our spacecraft that have made it to orbit haven't had any major flight observations. We've never actually damaged any of the cargo or been able, not been able to provide that service to NASA, which is the major important aspect of it. Again, I am focusing on the spacecraft, for a launch vehicle, any rocket design always carries big risk, and and there's an unfortunate mission right there. But in general, from a flight perspective for the spacecraft, we've actually never run into issues. In fact, we've only been able to extend mission capabilities to NASA. A little bit about extending capabilities. So not only on top of the major block modifications that I talked about, we've also been able to make minor modifications to the spacecraft, which has also been able to open up space to additional companies and additional industry partners. And again, while these were applied not strictly or explicitly from a DevOps perspective, they were actually put together using DevOps principles to try and work with providers early as possible and to keep that life cycle going. Instead of our operators, this is more of these secondary companies which needed ride shares or additional capabilities. So some of them are like the NanoRacks deployer. NanoRacks is a small company that specializes in getting CubeSats up into space. CubeSats, for those of you who don't know, are small satellites that are about the size of a loaf of bread. They're almost, when people say a 3U by 1U, it is, you can see in the picture there, it is something that is just about the size of a loaf of bread. And those satellites are short life, but they're able to be manufactured very quickly. The cost to build them and operate them are very low, so as long as they can find someone to launch on, and get deployed from, then they actually can close on a pretty strong business case depending on what they're doing. And I would just encourage you just to research some of the companies that are out there, and you'd be surprised at what a lot of them are doing. But NanoRacks was one where we were able to put the deployer on the side of our spacecraft, and we're able to complete multiple missions where they've been able to launch multiple different satellites. The Slingshot Deployer is another one, which is a little bit more recent. That one was interesting because they were able to do a lot of that installation with the crew, so you can see it installed on the hatch. So essentially what they would do is they would launch their equipment and their CubeSat on future missions, get those up to the space station, and once we got up there and left, the crew was able to install them on the top of the hatch before we departed, and then we were able to operate for them. They're able to put in hosted payloads that we can fly for them if they like, or deployers as well, like the NanoRacks deployer. And then the one I like to talk about a little bit is a plug for JSC. They were able to do a secret CubeSat, and that one, as a guidance person myself, I have fond memories of it just because the concept of that CubeSat is that it would fly away from the spacecraft and then do rendezvous operations with the idea that you could carry CubeSats with you in the future for human exploration missions, and if you couldn't send a crew member out there to inspect your spacecraft, you could send a small CubeSat, and it would kind of work like a drone and hover around and take pictures for you. Okay. So that was a lot of talking. I do see there's some questions in the chat. So I guess the first one, are emulators and virtual commissioning tools used for validation process in Cygnus or in engineering? Yes, the answer to that question is definitely yes. We have a whole different set of test platforms that have different levels of fidelity. We have test equipment that emulates how all of our major interfaces, if it's a ground station interface or if it's the space station itself. In terms of virtual commissioning tools, not really. I mean, that's not really something that we would have to do. We do all of our products are really contained within house because we only provide the service to the customer. So in some ways that answer is yes, but I wouldn't quite call it virtual commissioning. And then for tools to support the DevOps process. So, there is, I would say that tools are constantly under evaluation, and I would say that the biggest tool that I foresee, and this is just my personal opinion right now, that the best tool out there is still Jira. That's to be able to get those problem tickets moved throughout. That is not really the one that we used on Cygnus. A lot of our tools were homegrown, or there were various other tools that were put together. But a lot of the things that I'm seeing out of Jira right now are actually able to connect a lot of the engineering products that we do as just general systems engineers, and it is able to definitely take things beyond from, okay, I'm working just in the software development platform and I can use this and apply this to multiple other things. And I think that's actually all I had for presentation material. I guess I'll open up to any other questions.
No real-time spontaneous questions, huh? Look who we have here. Fire away. This guy knows everything. Dressler here.
Well, I will also say too, I do realize that this definitely goes across industries. So if feel free if you have just general space industry questions, you can feel free to ask me. Or if there's anything that wasn't really clear in my presentation, again, I promise I won't shame you. I've asked so many stupid questions my entire life. I guarantee you that I won't be the last time. I can't answer that question. No, but on that one though, I would say that there is probably enough data that exists on public sites like Wikipedia where you could probably do some rough cost numbers. And you could actually, there's a really good paper done by NASA, which you can search up, and they actually compared the cost of the commercial resupply programs to the space shuttle. And there's also another good report out there from the Office of Inspector General for NASA, where they actually go into a lot of the costs. So while I can't answer that question, there is data out there where you could certainly find the answer to your question.
So, Sean, which one are you referring to? The one from GPDIS 2020?
I'm sorry.
DevOps? Which question are you referring to?
Oh, there was a question from Cheryl Peck on how much does each mission cost? Paul, that's yes. Thank you, Paul, for bailing me out there, because I do know that we have a ton of other tools as well. Okay, that's a good one. Russ Brown asked, what are some of the hardware emulators developed on Model Center? Yeah, so we do use Model Center. We also do use Cameo as well. The hardware emulators, though, it is a little bit tricky because some of them have very specific requirements that are unique to NASA hardware. And some of them are actually government-furnished equipment. I will tell you that we've definitely done emulators that were supplied as government-furnished equipment, and we pulled them in and started working with them and realized that they were not really good emulators. And that's not a knock on our customers. It's just that the space station is huge, and when they saw what we were using the emulators for, they realized, oh no, that's not what you want to use. And then we actually brought them in for a bit, and then we did a couple quick working groups. And within a week, we were actually able to homebrew something up ourselves. That one definitely wasn't done with the Model Center, though. That was definitely done through just hard brute force engineering. Patrick asks, with regards to the performance schedule and sequencing of space operations, do you depend on a NASA bill of material or must alter your own BOM? What is the challenge to connect the dots between planning organizations for program excellence? That is a really good question. So I'll answer it, but I'll provide the context that I'm the chief engineer, not the program manager. In general, it's always done with a look ahead. So if you look at the Series 2 contract, we are actually contracted up through NG17. So we always do bulk orders as much as possible. From a NASA bill of material perspective, no, NASA doesn't really provide us a bill of material. It's definitely all on our own. Although it does have to be worked with close connection with NASA. So we have a very strong relationship where we understand what their needs are, and it's no secret. I mean, they project out their needs to basically the entire industry to say what they believe that they're going to need for the space station, because that goes into requesting the budgeting from Congress as well. So it's no real secret to see exactly what services that they need, but the challenge there is though trying to predict out as far out as you can, just because you don't really know what's going to happen. If for instance with the shuttle retirement, and also as well with the commercial crew coming up, commercial crew didn't really come up as fast as some people originally predicted, and there is a gap where they really weren't able to get a lot of crew members onto the space station, which definitely changes their use cases and also changes how much cargo and logistics services that they actually need. So those are the types of things that you just try to predict out as far as possible, and it's constant planning. That's really the answer, is that you just have to constantly plan. Natalie asked, have you gone through a large remodeling process to integrate everything you need for successful trades, or are you using original Cygnus models? How has this changed in DevOps? Also a really good question. I would say that the remodeling process isn't, that's not too large. I mean, most of what we've been doing on the Cygnus on the Cygnus program has been able to be carried us through for most of the product line. Although I will say that we have changed some of the tools and adopted additional tools over the time to manage the product line. And in general, we are our process and how we do things hasn't really changed. And once we bring in a new tool, our team size is pretty large, so it definitely is not it's not a trivial process to try and bring on a new tool and get the engineers to use it. My experience is, and I've actually had to do this to bring in a new either configuration management tool or a tool like Jira, for instance. Most engineers are pretty adaptable, and you can pull them in and have take them offline for one day to get them as much knowledge as possible into their brains so that they can start using that tool, and then having them use it, and then just providing a few engineers that are able to service and help them manage that. Some engineers are definitely more responsive than others, but I also find too that in this day and age, especially through the whole process of DevOps that I've seen from the turn of the decade to now, almost people expect a new tool change. I usually expect a new tool change every 2 years or a major improvement. So it's I would say that it's definitely focused on the people. That's the #1 focus right there. Okay. Well, I definitely do encourage discussion. So if any of the questions didn't quite, if my answers didn't quite hit what you were looking for, feel free to ask away. I put myself on camera so I can't hide.
We have, there we go, Paul Nelson, automating every step.
Yeah.
Here you go. That's a great one, Paul.
Yeah. So we actually do have a lot of automation beyond software development as well. So the way that we handle problem tickets, we don't actually necessarily. We do have a problem center for our software team, but we also apply that just in general for all of our engineering drawings as well. And a lot of those processes actually are automated, where an engineer or a technician on the floor will put in something that they found, and that actually goes through and automatically goes out to the stakeholders that we assign. And now, obviously, with any tool, you have to rely on the fact that you have the right team members assigned to those reviewers. So if you are going to automate something, you are relying on the system. But even as well, just for making programmatic level decisions, if it's through a engineering review board process or a change control board or whatever terminology you're using, where you are basically pulling people into a room to make a decision on should I change this or what should I do in this case. A lot of those tools are automated as well to kind of push them forward so that they can, once we bring people into a room, especially now when everyone's working virtually and our time is so valuable, and we have to keep everyone focused for a short duration of time, you have to get that information out to people as fast as possible and to get them all reading ahead so that your decision-making time in that room, as opposed to having 2 hours to talk about whatever the decision is to try and educate everyone on it, that turns into a 30-minute, I've thought about it and I agree. And if everyone agrees, you might be in and out of that in 10 minutes. And you only use that time if people don't agree, and then you figure out how you're going to come to a consensus. Okay, so Paul also asked, GPDIS is an interoperability form. What has your Cygnus experience been with the supply chain on your ability to exchange models of potentially different formats, flavors? What pain points of success have you had? Oh, man. Okay, so I will say that developing a product line service for a space customer to try to get a with enough missions, you can definitely get a supply chain set up. The orders that you put in, though, it's not the same as if you're in like the automotive industry, or if you're developing, let's say if you're Google and you're developing Chromecast that are going to go out to millions of customers. So the supply chain definitely is, it's definitely different. We do have a whole supply chain team that is focused on just making sure that all that information is available to all the engineers, so that way we can also recompete certain items. As I said, we focus on trying to use standard interfaces, so if one vendor doesn't really do a good job or they're not performing, we have 3 more options available at our disposal. And that actually has happened before in the past. We've had vendors that have just been really tricky or difficult to work with, or they just weren't as good as other options, and we've gone through those learning growths and just said, okay, fine, we're going to have to go off and make a change and make a block modification on the spacecraft. Some of our key areas of success, I would say, is just being able to pivot off of one vendor. We've been able to do that in under, I'd say, probably like a 1 to 2 year time scale. We've been able to develop a plan to switch off to using another component and get that in without actually affecting any of our deliveries for our overall spacecraft. Okay, so Tom asked, these missions require software as well as hardware testing. Do you now just use software to test all of this? So we do have a software development plan that, of course, that would definitely be more of the traditional, software workflows and design and development plans that you're used to seeing. At the end of the day, though, it always comes down to software and hardware interactions. So all of our software, while it will get tested in a emulated environment, it will eventually make its way onto the hardware, and then we'll be doing system level testing where we pull in our software engineers to be able to test all of that. Sorry, my screen locked up. So Paul asked, just to clarify the question, for your systems models, do you ever face data exchange challenges with customer NASA or partners? Oh yeah, 100%. You know, your customers don't never work the same exact way you do. The one nice thing I will say about NASA JSC though is that they're just as focused on model-based engineering as much as we are. So a lot of the times we really just have to we just have to provide enough runway to get them initial drafts, early drafts of models so that they can go in and incorporate it into their models, as well as vice versa, and then try to work with as much preliminary information as possible. One of the barriers that we try to break down is the concept of, if I'm giving a deliverable to a customer, then I'm immediately going to be graded on that deliverable, and I want to wait until that deliverable is perfect. And that is true. You definitely don't want to look like an idiot in front of your customer. However, if you both agree that you're not working with complete detailed requirements, or if for whatever reason you know, you're in a development process, then to make sure that you get a schedule of those draft deliverables forward. So most of our challenges have usually been the reluctance to share information because people are worried that it's not perfect information and, you know, it's going to cause more problems. I actually find the exact opposite is true, and especially from a DevOps perspective, it's that you want to try to get those early revisions through so that way you can get them commented on as early as possible. Because if you're doing something wrong, you want to know earlier. So I would say that's probably the biggest challenge in data exchange. So is Jenkins becoming a value for you in this type of DevOps flow? So I'm not as familiar with Jenkins, so Russ, you may have to school me a bit on that particular question. Oh, digital sim test tool. Okay, so I would say that on this program we don't actually use that. Most of our simulation tests are actually homegrown, and we develop them internally, and that's only because for a lot of the modeling that we do for our spacecraft, it's very specific to our application, and we have our own internal modeling software which we use to create a space environment and to create the spacecraft. So I would say no, but you know, if ever someone came up with a commercially available spacecraft modeling, I mean, for those of you in the space industry, you know that SDK works as well, but to try and come up with the detailed models of a complete integrated spacecraft, it's not quite what SDK is set up for. So usually what we have to rely on is bringing in a multitude of tools together. Yeah, so again, again, for like most of our simulations and our modeling, those are not tools that we typically use. Thanks, Russ. I appreciate it.
Yeah,
I would be curious to know exactly what applications you're using this for, because I'm going to have to do a little bit more research on those, just to see if maybe they would apply for some of the work that we're doing.
Are you referring to Jenkins?
Yeah.
Or,
Well, actually, yeah, Jenkins and Questa.
well, Russ, I believe, is Northrop Grumman, and Russ, if you want to reach out directly to Sean, certainly do so. I think that'd be a great idea, and that would help us continuously improve, integrate, and do the thing that we're talking about.
Yeah, and I can also put you in touch with some of our software engineers that are specifically working on the program, or for modeling. Typically, in modeling for spacecraft, we're looking at performance. So, from myself, for like the modeling that I'm used to doing, I'm used to running multiple sims through like a Monte Carlo perspective. So I'm taking a cluster computer and running like 500 missions within a couple days just to try and gather performance with perturbations throughout. And again, like a lot of that is homebrewed stuff. But yeah, no, thank you. I guess once again, thanks Tom and Ryan for getting me on here, and definitely always like talking about the company, and always like sharing stuff about the space industry. Hopefully you found it informative. And again, if you have any other questions or comments, feel free to reach out.
Yeah, Sean, and before everyone else bails, we're going to try to launch again tonight. The tentative schedule is 9:16 p.m. Eastern Time. Please talk about that. That's important. It's a follow-up to your great presentation, and I am grateful that we've been able to get your time to do this.
Yeah. Oh, yeah. And Tom, thank you for reminding me, because I totally would have forgotten. So the NG-14 mission, which I did put a shameless plug here in my office, just to give some background information or background flair. No, so the NG-14 mission it's on schedule for tonight. I'm actually getting text messages as we speak. They're going to try again. The setback was just a minor issue that they had with the launchpad GSC, which they actually think they have that figured out now. So we're going to try and go again at 9:16. And for those of you that are on the eastern seaboard, if you look up, if you're close enough to the shore, you'll definitely be able to see it. It's going to be taking a southeasterly track, so that means it's going to be launching off of Virginia, Wallops Island, Virginia. So for those of you for the eastern shore, that's basically the bottom of that peninsula below all the Maryland eastern shore towns. And it's going to pretty much follow the coast and head over to the southern tip of Africa.
I think
it will be streamed on NASA Live as well. So for those of you that aren't on there, but you just don't want to see it, you can definitely watch it on NASA live stream, which is on YouTube.
Sure, space.com has it a number of places. We'll stream it as well. And I was, as I said on the outset of this conversation, I was there last night waiting, and all I can think is, it's Chincoteague, and what is that? Beaches and ponies and rockets. Oh my! It was really spectacular just to be there. And
I will say that one of the nice things about the area, we're able to not only provide additional service for NASA, but we're also able to provide an additional launch center for NASA too. I mean, the Wallace Flight Facility always existed, but we were able to do a lot of that development work, actually some of it with the state of Virginia, to put together a spaceport. So it just gave NASA an option to be able to launch medium-class rockets like Antares and send spacecraft like Cygnus up to the space station.
So everyone, going forward, this was the former PDS-TV track. We retooled it, rebranded it to DevOps, which is, as folks joined a little bit late, why is this called DevOps? We're just making it more inclusive, more relevant, more current. And in the future, we hope to include DevSecOps specific type of topics. But this year, we changed it. We went virtual. And Ryan and I reached out. I had a little bit of help from an incentive from Paul Nelson, motivation, and we were able to get Sean. I'm excited, pleased, and grateful, Sean, that we were able to get your time for this. Sean, I think we did great, pulling this together. The whole GPDIS team. This is the first session. the first virtual session. There's 7 more to follow. Generally, we're all together for a week. And I think, Sean, honestly, Kenny, if you're still there, if the rest of the sessions go as well as this one, I think we can call this virtual conference a success.
Well, definitely glad to be part of it, Tom.
Ryan, any parting shots, parting thoughts? Ryan Tracy?
No, just thanks for coming and speaking with us today, and thank you to everybody who attended. And have a good weekend, everyone. Thanks.
So I guess that's it. If there are no questions, then we'll go ahead and wrap up and terminate this segment of the GPDIS 2020 virtual conference. Thank you all, folks.